Alright, hey everyone, Maya here, and it's been a while since I did one of these Mathelingual videos, but it's given me some time to figure out how I want to go about doing these videos. So, first thing we're going to do is obviously flip the board. I've still got the inspirational quotes on the side, just in a different color. But today we're going to wrap things up on talking about absolute value equations and, well, expressions. You get the idea. So what we're doing first is a multi-step absolute value equation. So I know this green marker shows up a little wonky on the camera, so I'm trying to dictate what I'm writing so you can still kind of get a sense of what I'm going through. Alright, so we've got, for example 1, we've got 3 times the absolute value of x plus 2 minus 1 equals 8. Okay, so what we're going to do first, you have to isolate the absolute value quantity. So what we're going to do is we're going to add 1 to both sides. So we get 3 times the absolute value of x plus 2 equals, because this cancels out, 9. Then we're going to divide both sides by 3 to further isolate that quantity. So we have x plus 2, the absolute value of x plus 2 equals 3. Now we've seen this kind of equation before. We can solve this because we know by now, we should, at least if you've covered this material or you've watched any of my previous videos on this topic, the absolute value of x plus 2 equals 3 can be written as 2 separate equations to solve. So what this means is the distance of x plus 2 must be 3. So x plus 2 may equal 3, or x plus 2 equals negative 3. Alright, now we can solve this. X plus 2 equals 3, subtract 2 from both sides, x equals 1, or, on the other equation, subtract 2 from both sides, negative 3 minus 2 is negative 5. So these are our two solutions, x equals 1 and x equals negative 5. And if you were going to plot these on a number line, you would have, let's see, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1, 2. So you'd have negative 5 and 1. Okay, so now we do need to check, because there are cases where you can get something called an extraneous solution. I hope I'm saying that right. I know it by spelling, but it's one of those words I always kind of second guess myself on pronunciation. So to check, this is how you check. What you must do, you must take each of your solutions and plug it back into the original equation. And it has to check out, otherwise we cannot consider it a true solution. Okay, so let's start with x equals 1. 3 times the absolute value of 1 plus 2 minus 1. Does that equal 8? We're going to put a question mark above the equal sign because we're not sure yet. So let's simplify. 3 times the absolute value of, well, 1 plus 2 is 3, minus 1 is 8. Well, 3 times, well, absolute value of 3 is 3. So we just have 3 times 3 minus 1 equals 8. And we can confirm, because 3 times 3 is 9, and 9 minus 1 is definitely 8. So this checks out. 1 checks out as a solution. Now similarly, we're going to do the same for 3 times the absolute value of negative 5 plus 2 minus 1, and we're going to still have that question mark because we're like, does this equal 8? So 3 times the absolute value of negative 5, our solution, plus 2 minus 1. So negative 5 plus 2 is, of course, negative 3. Then you've got your minus 1 equals 8. And the absolute value of negative 3 is 3, because it is 3 units away from 0. So then we're just going to simplify like so. 9 minus 1 equals 8. They both check out. Okay, So I want to talk a little bit about a few things before we move on. So this is the key with understanding absolute values. So pay attention, okay? Grab a paper, a pen, or a notebook or something, because what I'm about to tell you is pretty important when it comes to absolute value. Okay, so when it comes to absolute value, the key is we're talking about distance from 0 on the number line, okay? Distance. So you cannot have a negative value for your number. So you can have a negative value in your absolute value bunch, your absolute value lines. So you see how we had here? The absolute value of 3 is 3 because it is 3 units away from 0. And the absolute value of negative 3 is also 3 because it is also 3 units away from 0, just in the other direction on the negative side, okay? But your distance can never, never, never be negative, okay? Those two kind of go in hand with alliteration. Never, never, never. Okay, so if you ever get an absolute value equation solution, like the absolute value of x is negative 5, that's no. So if you start out with something like the absolute value of x is negative 5, that's an equation that is not going to have a solution, because how can the distance of a number x be negative 5, right? So, like I mentioned about the extraneous solutions, always check your possible solutions for your equation, because one or more of the possible solutions you have could be extraneous, and that means you get it from solving your equation like normal, but it's not a solution of the original equation. So just because you get a solution from your equation, don't assume it's an actual solution to the problem, because sometimes it isn't. So that's why it always pays off to check. Check your work, show your work, because that kind of can be the make or break it as far as whether or not you actually have a solution. Okay, so I'm going to show this with another example, and this time we will actually kind of be dealing with, well, not kind of, you're either dealing with it or you don't, right? We're actually going to be looking at a case where we get some solutions, but one of them is going to be extraneous, okay? So pay attention, because this is similar to the last problem we just did, in that you're solving it using the same kind of methods. So what we've got here is the absolute value of 3x plus 2 equals 4x plus 5, okay? So we can solve this using two equations. So this means 3x plus 2 equals 4x plus 5, or 3x plus 2 equals the negative of 4x plus 5. Now don't get confused just because this is a huge expression on the other side instead of just a regular number. We're still just taking the negative of this quantity, okay? So let's start over here. Let's simplify over here. 3x plus 2 equals, the negative of 4x plus 5 is negative 4x minus 5. Okay, so on the left-hand side, 3x plus 2 equals 4x minus 5. What we do, subtract the x's, get that out of the way. So subtract 3x from both sides. This cancels out. 2 equals x plus 5. Then subtract 5 from both sides, and that means x equals negative 3, okay? And then over here on the right-hand side, we're doing the same, we're using the same method. So, okay, what I'm going to do, I'm just going to add 4x to both sides. It doesn't matter which x you bother, as long as you do it to both sides. So 4x cancels out on here. 3x plus 4x is 7x plus 2 equals negative 5. And then we're going to subtract 2 from both sides. And this cancels out, so now we have 7x equals negative 7, right? And x equals, when you divide both sides by 7, you get x equals negative 1. Now don't assume these are both solutions. We have to check. That is a mandatory part of the process. Check. Okay. So does, when we plug in negative 3, 3 times negative 3 plus 2, does the absolute value of that equal 4 times negative 3 plus 5, okay? So let's see, 3 times negative 3 is negative 9. plus 2. And then we have 4 times negative 3, which is negative 12, plus 5. Negative 9 plus 2 is negative 7. And negative 12 plus 5 is negative 7. Okay? But remember what I said, your absolute value cannot be negative, so let's see where this goes. Absolute value of negative 7 is a positive 7 because it's just 7 units away from 0. That is not equal to negative 7. So this is not a solution. Not a solution. Okay? This right here, so we can label this is our extraneous solution. Okay? Because we derived it from solving the original equation, and yet it does not actually make the equation true. Now let's check what x equals negative 1, just to be sure. Always do this no matter what you get, because it can mean the difference between whether or not your solution actually checks out. Okay, so similar process, 3 times negative 1 is negative 3, plus 2 equals, does it? Negative 4 plus 5, negative 3 plus 2 is 1, equals negative 4 plus 5 is 1. The absolute value of 1 is 1. So this checks out. So this is a solution. This is a solution. Okay? So this is our solution. This is not. Okay? So this wraps up my next video on absolute value equations. So we went over the multi-step and the extraneous solutions. Hopefully that was a little insightful for you. Particularly, I know it's easy to kind of get these absolute value solutions and equation solving kind of mixed up because, you know, it's a different kind of algebra you're dealing with. You got to split it into 2 equations, but like anything else, with practice, it gets easier to do. So that was insightful, and until then, I am out.